Alright, this is our first lecture on section 3.5, rate of change. Our objectives are going to be to calculate a rate of change for a quantity, understand why slope is a rate of change, and use rate of change to find a linear model, and then also to know this slope's addition property. So first of all, a unit ratio of the slope is called a rate of change. The slope is a specific rate of change. It is a constant rate of change, and not all rates of change are constant. Sometimes they vary from 2 points to another 2 points. So rate of change is a more important quantity in our application type problems, and what it is just the dependent change to the independent change. The same thing that we knew before, our y2's minus y1's over x2's minus x1's. Sometimes that difference is called something called a difference quotient, and you may hear that again if you go on and take a calculus class eventually. So difference quotient is what we think of as the slope formula. And then what this yields is a single number with a ratio of units. It's the dependent units to the independent units, and that's quite important. So we're going to go ahead and we're going to do an example. We're going to do exercise number 10 in your book on page 164. So we're going to be looking at Lehman's book here. So moving this up so we can see it a little bit better. We have the percentage of firearm applications that were rejected declined approximately linearly from 2.4% in 1999. So we're going to write that down. 1999 is our independent value, right? Because depending upon the years is what the firearm percentage is going to be. So 1994. It was 2.4%, or excuse me, 1999, it was 2.4% to 0.09% in 2007. So 2007, it was 0.9%. And what we have here is we're going to set up the difference quotient for the rate of change. And I'm just going to call that R of C. So the rate of change, the difference quotient, we have a 2.4 minus a 0.9 over 1999 minus 2007. And what we're going to notice here is that this gives us a 1.5 and this gives us a negative 8. And remember, it did decrease. The slope, the rate of change, is decreasing, so it's a negative quantity. And now we're going to divide this out. Unlike our slopes, where we leave it as a ratio of a whole number to a whole number, we're actually going to divide it. So we're doing 1.5 divided by an 8. And so when we do that, we get 0.1875. And then we have the units, which are also very important to us, and those units are going to help us in our application problems. So that will be very important to write down as well. And those units are the dependent units, which are percentages per year. And so what this says is that every single year, the percentage of firearm applications is decreasing by 0.1875%. And so that will be our final answer. Oops, I missed that one there. So now, in the next lecture, I'm going to show you how a slope and a rate of change are actually the exact same things, and how we can interpret that in a visual respect.